Shh. 102. How many people have completely finished pages 101, 102? Completely finished it. That's what I thought. That's because my other class also had not done it. Have you finished it all? Oh, that's okay. I'll show you how to do B. Okay. I have to say that this is the reason why my enriched class can go at twice the pace, because when I assign them homework, they do the homework. And then they come and they ask a question if they have the question. And if we look on Teams, pages 101, 102, if the quiz was at all hard, review those sections and come in for help. So at any rate, I'm feeling fairly frustrated because if you guys want to be prepared for Chemistry 12, we need to finish this course. We cannot finish the course if you are not willing to put in the effort to do the work at all. Like, it just is not going to happen. That was longer than I meant. Sorry. Like, if you're like, oh, I just hope Chem 12 will be okay, even though I don't know how to do dilutions because we didn't get around to that, and even though I don't know how to do limiting reactant because we didn't get around to that, and even though I don't know how to do all these things because we didn't get around to it because I didn't do my homework. So we're going to learn this again today, even though we learned it last Thursday. So when we are finding a new concentration, to find new concentration. Now, number one, you have to find the moles. And number two, you have to divide moles divided by the new volume. And that new volume is going to be in liters. Okay? So how do we find moles? We're going to take our 37.5 milliliters. Remember, how do we change that into liters? Divide by 1,000. 1, 2, 3. So that's going to be 0.0375 liters. What does of mean? Of means times. Okay? What does 0.0600 molar mean? What does molar mean? Moles over liters. So we're going to say 0.600 moles per liter. We do that math and we get 0.0375 times 0.6 equals 0.0225 moles. Now we've done step one, we have found the moles. Now, in order to find concentration, we take the moles and divide by the new volume. So how do you show that? On a separate line, you write concentration of Na2SO4, and you can write DIL, that stands for diluted, or you can write nu. So if you didn't want to write dil, you could write nu. Or if you didn't want to write nu, you could write F. What would F stand for? final. Yeah? You can write any of those. I'm going to write Dil. Okay? Concentration is always the moles over the liters. So we're going to take our 0.0225 moles, and that is in our new volume. It says our final volume is 250 milliliters. 250 milliliters. Can I do that? No. What do I have to change it to? I have to convert it to liters. So once again, how many places do we move our decimal? 1, 2, 3. So that's going to be 0.250 liters. Do the division. 0.09. And you can either, how many sig figs? 3. So we need a 0, 0. You can either write it as moles per liter, or you can write it as 0.0900 molar. That's fine. Yep. You can also write it like this. You can extend that and make it longer. It doesn't matter. Okay. Now, second part of the question. This is a little trickier. What is the concentration of the sodium ion? Now, the thing we need to remember up here is that really what this is moles of Na2SO4 per liter. Yeah? So what we can do is we can say, let's start with, I want to find my concentration of Na plus. So I want to find the moles of Na plus per liter. And we are starting with 0.0900 moles of Na2SO4 per liter. What do we want to cancel? Yeah, we want to cancel the moles of Na2SO4, so that needs to go down here. Moles of Na2SO4. And we need to find the moles, yeah, of Na plus. What numbers go in there? Yep, so we have 1 mole of that. And then we have 2 moles of the Na, because it's Na2SO4, 2 moles. And so that is then going to be 0.180 moles of Na plus per liter, or you could just write it as 0.180 molar Na plus. Now, on Thursday's test, you are expected to be able to do these dilution problems. So if you have not yet done them, what you are going to do is from page 100, page 100, page 101, page 102, you are going to complete those. As soon as you complete them, you can get last day's quiz back. If you have not yet written last day's quiz, talk to me about that and we can get you a copy of it and you can write it today, or if you need to make another arrangement, let me know. Okay? So, yes. Do you need to write the quiz? Yeah, okay, I'll grab you one. Yes. Yes. Page 103. All right. So in our back prep room there are a bunch of solutions called stock solutions. Okay? And these are solutions that have a fairly high concentration, page 103, of solute. They're really handy because it makes it easier to make more dilute solutions by just taking the stock solution and adding some water rather than having to measure out the mass, like you guys did in your procedure, measure out the mass, transfer the mass, add the water, swirl, 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 swirl. Oh, keep swirling because it's not dissolved yet, right? If you do it this way, your solute is already dissolved and you don't have to be you just measure out a volume, which is much easier to do precisely and quickly than it is to measure out a mass. Masses, you got to add, oh, I got too much, I got to take it away, I got to add more, I got to take it away. It's a big pain, okay? So if we have 10 molar hydrochloric acid, which could also be written 10 HCl, that is a very concentrated acid, we could dilute it 1 in 10, which means 1 liter of water plus 9 liters of, 1 liter of acid plus 9 liters of water, 1 in 10. Yes? That would give us 1 molar, 1/10. Yes? Or we can dilute it 1 in 100 times to get, and I'm sorry, this should say 0.1 molar, because that is 1/100th of 10 molar. Yeah? So here is how we make a diluted solution. We take our stock solution, which is concentrated, and we figure out how many moles of solute do we need in our final solution. So we're actually doing calculations with, we want to know how many moles are in here, right? I know what I want, okay? I know I want a particular volume at a particular concentration. And if I know volume and concentration, I can find moles. Yes? We okay? Okay. So over here, I'm like, how many moles do I want? We're going to figure out how to do that calculation. And then you say, what volume of stock solution contains that many moles? What volume of stock solution has that many moles in it? And then you just measure out that volume. Don't worry about the calculations just yet. We're going to go over that on the next page. So you measure out whatever volume that is. You put it into a new volumetric flask. Yes? And then you add water. There it is in our new volumetric flask. And then we add water up to the new volume that we want. Okay, and now it has been diluted. Just like before, though, you always have to make sure you stopper it, and then what do? You invert to mix, okay? Now, the math for this. Step number 1, just like the other dilution problems, what was the step 1 in the other type of dilution problem? Find the moles. So we want to find the moles, and in this case, it's the moles of solute you need in the final dilute solution. And you will have the liters of the dilute solution, you will have the molarity of the dilute solution, and so you'll be able to calculate the moles, just like you did for the past problems. And then you figure out what volume, this is where it's different, of the stock solution contains that many moles. So for example, let's say we want 2 liters. Okay, here's our picture. See, it's 2 liters. Okay, and we want it to have a concentration of 2 moles per liter. This is the solution. This is our end solution. This is what we want. We want 2 liters, and we want it to have 2 moles per liter. Well, if each of these is 1 liter, right? This is 1 liter. This here is 1 liter. How many moles are in the top half if I want it to be 2 moles per liter? How many moles do I need in the top liter? 2 moles in 1 liter, right? How many do I need in the bottom liter? I need 2 moles in the bottom liter, and that gives me 2 moles per liter, right? I have 4 moles in 2 liters, which gives us 2 moles per liter. Yes? Okay, so now I know we need 4 moles to make that solution. All right, now we have a stock solution, which is the concentrated one, and we want to know how much of that 8 molar stock solution do we need to get those 4 moles of dots. Well, let's start with 1 liter of 8 mole per liter. So this is 1 liter. How many dots should be in there if I have 8 moles per liter? 8 dots. Okay, easy enough, right? 1, 2, 3, 4, 5, 6, 7, 8. How much of this do we need to get 4 moles? Do we need the whole thing? We need half of it, right? So we need half of it. So that right there is 0.5 liters of 8 molar dots. Contains 4 moles. Okay, so what we would do is then we would take this .5 liters and we would move it over there, and then we would add 1.5 liters of water to bring our final volume up to 2 liters. Okay, now I actually find the pictures for this one quite confusing because it's almost like you're trying to work backwards, right? And I don't know. It's not as intuitive as the other one. So let's do it using conversion factors instead. We want two liters of 2 moles per liter solution. Well, the math on that to find the moles is really easy. We say we have 2 liters. What does of mean? Times 2 moles per liter, and that gives us 4 moles. That's how much we need. Now we want the volume of the stock solution. What is the concentration of the stock solution? 8 moles per liter. What volume of the stock solution gives us 4 moles? What do we need to cancel? Moles go on the bottom. And what goes on the top? Liters go on the top. 8 moles per liter. Yes, we flipped it upside down. That's okay. So now we have 4 divided by 8 is 0.5 liters of 8 molar stock needed. So we would take those 0.5 liters and we would dilute it to a final volume of 2 liters. Does that kind of make sense? Maybe not. Yes, I think it's much easier than what we did on the quiz. So basically what you're doing is you're saying, I need to, step 1, find the moles, which is just like what you did today, right? And instead of finding the molarity, this time you're going to find the volume, but you have been given the molarity. Okay? And we're going to talk about the rest of this next day. Your homework, if you have not already finished it, is to do all of pages 100 to 102 and figure out what's wrong with your quiz. Okay? If you want to redo it, tomorrow or Thursday is the day, or tomorrow or Wednesday is the day because your test is on Thursday. Okay? Come see me. Ask me questions. We've got another 5 minutes right now. I'm happy to answer questions about quizzes. Hi.
I have a question.
Yes.
Over here, I was getting confused. From here, I got